How is a composition of reflections across parallel lines related to a translation? Well, we have triangle A at -7, 2 is A, and B is at -6, 6, and C is at 5 or -5, 1. So hard to write with this pen. Please try to be really precise in your drawing. It's going to be easier for you to see. So we have line M is the line x equals 4. So that means that line M is this line right here. It's an invisible line that we have on this graph everywhere that x equals 4. That's a vertical line. That should be a review concept for you. The first thing we want to do is reflect triangle ABC across the y-axis. So we're going to reflect it across the y-axis. So if you recall, the rule for reflecting across the y-axis was back on, I believe it was page 5 of your packet. And reflecting across the y-axis, we switched the sign of the x value. That's all we did, right? So if we switch the sign of our x value for step 1, we would just change A to being +7, 2, and B would be +6, 6, and C prime would be +5, 1. So we would have a point at 7, 2, a point at 6, 6, a point at 5, 1. So reflecting it across the y-axis moved it to here. So we had our next step. Let's see what color I want to use. Go with this one. Step 2, they wanted us to reflect it across line M. So it's already been reflected, and since this is step 2, we're going to be doing this process to the new shape. So we're going to reflect it across here, and so we would just go 1 over, and this one would go, instead of being 1, 2, 3, it would be 3 to the left. And this one up here, instead of being 2 to the right of that line, would be 2 to the left of that line. So we would have A double prime and B double prime and C double prime. Hit it, the line. So when we have a composition of reflections, we flipped it over and it was facing the other direction, and then we flipped it back. So now it's facing the same way it was to begin with. So if I reflect across parallel lines, so we've reflected, the parallel lines were here. We had the y-axis was parallel to that line x equals 4. So if you reflect across both, and we can go ahead and write that A prime or A double prime is at 1, 2, and B double prime is at 2, 6. C double prime is at 1, 2. 3. Okay, so we have those there. So what we're seeing here is that when you have reflections across parallel lines, you end up with basically the same thing as a translation. So if we were to write this out of what happened, we had reflection across the y-axis. We read in notation. But what happened to that was a reflection across M. This pen is so hard to make an open circle. So that was the composition that we did. We had step 1, then step 2. So notice that step 1 is on the right and step 2 is on the left. Okay? But what is happening here? Well, there is actually a line that is perpendicular to each of those points. That causes that reflection to really just be slid over. So that leads us to, we're actually just going to skip this, try it today, and go down here to our translation composition of reflection theorem. So we have our theorem. Of course, you guys are highlighting these, right? And you're keeping your packets because you're going to want to come back to these theorems and definitions throughout the entire chapter. So this says a translation is a composition of reflections across 2 parallel lines. Both reflection lines are perpendicular you could use just the symbol perpendicular if you want, to the line containing a pre-image point and its corresponding image point. The distance between the pre-image and the image is twice the distance between the reflection lines. Between the 2 reflection lines. So let's explore what this just said. A translation is a composition of reflections across 2 parallel lines. That's what we just did. Over here, step 1 would have been flipping it over to the orange picture on the right, and step 2 would have been flipping it back to the middle. So the distance between those parallel lines, M and N, was created across. So there's this parallel, or there's this line that's perpendicular to these, so that's 90 degrees right there. And the distance between those 2 things is double the distance of D. So coming up here, and let's go back and look at our picture. The distance between the y-axis and B, this distance right here, is actually 4, right? The distance between where we started and where we ended, the final distance, is 8. Notice that that total distance is exactly twice the distance between those 2 lines. And that relationship will always exist.